Hello class. Congratulations on being done with chapter 3. We are now starting chapter 4, which is actually something besides lines. We're actually going to get into triangles now. And we're going to do triangles in chapter 4, 5, and some of chapter 6. The first thing I want to talk about is we're looking at a triangle, and the measurements in the triangle are angle X, Y, and Z. But as you can see, there's a set of parallel lines. And I want to take notice too, because of parallel lines, you could say that alternate interior angles are congruent. So I could move X up here because alternate interior angles are congruent. I could also move Z up here. So these two angle measures, X and X, have to be the same, and these two angles measures, Z and Z, have to be the same. Well, what must X, Y, Z up here add up to? 180. So that is the proof why in a triangle, all three measurements, X, Y, and Z, have to add up to 180 degrees. So today, we're going to be talking about the interior sum of any triangle. So our next slide is just writing out exactly what we just learned. So if you want to take a second and try to unscramble, go ahead, pause the video, and then come back and I'll have it filled in. So what we came across is that the sum of the measures of the interior, forgot the R, interior angles of a triangle is 180 degrees. The sum of the measures of the interior angles of a triangle is 180 degrees. So if we go to our next slide, I have this question and I'm asking you, what is the measure of angle ACB? Well, ACB is right here, so it's 3x. So I want to know what the actual measure is. Well, if I know they all add up to 180, then I can simply take 3x plus 4x plus 2x and set it equal to 180. Go ahead and solve. Please note that x is 20, and that's not our final answer. Okay. So 3 times 20 is 60. So my final answer is that that angle ACB is 60 degrees. The next slide we're going to be talking about is the classification of triangles by their sides. Now there's 3 classifications. There's scalene, isosceles, and equilateral. I'm sure you probably already know what equilateral means. I'm sure you've already probably seen isosceles, and then if you could figure out scalene. So a scalene triangle, if we classify it by its sides, is a triangle that none of the sides are congruent. So no congruent sides. Isosceles triangle has at least 2, and I say at least because we'll talk about that in a second, but it has at least 2 sides congruent. Okay, at least 2 sides. And then lastly, we have equilateral. Equa meaning equal, lateral meaning sides. So 3 congruent sides. And if you think about it, if it's equilateral and at least 2 of the sides are congruent, it's also isosceles. So it goes back to that every equilateral triangle is isosceles, but not every isosceles triangle is equilateral. So you got to keep that in your mind. The next two slides are classifying triangles by their angles. And of course we have right, obtuse, and then we have acute and equiangular. So I'm sure you can figure out what most of these are. If a triangle is considered a right triangle, then it has one 90-degree angle. So I'm going to put one right angle. If we know that a triangle has 180 degrees in it, could it have two right triangles? No, because if this was a right angle and this was a right angle, that's already 180 degrees. And a triangle has to have three sides and three angles. So it can't be two right angles. Obtuse, it has to have one obtuse angle. Again, the same rules apply. If this was greater than 90, let's say 91, and this was 91, 91 and 91 is larger than 180 degrees. So it is impossible to have two obtuse angles. So that's why you just have to double check that if it has one right angle, it's right. If it has one obtuse angle, it's obtuse. Acute triangle, for it to be acute, all three angles have to be acute. So all three acute angles. Okay, and equiangular, obviously meaning equal, and in angle means three congruent angles. Now let's think about this. You know that the interior sum has to be how much? 180. So if it has to be 180 degrees and all the angles have to be congruent, and I can show they're congruent by going like this. So if all those angles have to be congruent, and we know they have to sum up to 360, 180, 3x equals 180, x is 60. So each angle in there is 60 degrees. Well, if every angle in there is 60 degrees is acute, which makes every equiangular triangle acute, but not every acute triangle has to be equilateral. Example, 50, 60, and 70 would make a triangle. 50, 60, and 70, because 50 and 60 is 110, and then 70 would make a triangle that's acute. So every equiangular triangle is also acute, but not every acute triangle is equilateral. For the next slide, I'd like you to take a second and go ahead and try them on your own. Go ahead and pause the video, maybe just write a small A, S, or N, and see if you can get what these would be. And try it on the next slide too, and then come back to the video and watch. So make sure you pause it. Okay, the first one, a polygon is with three sides. First of all, the definition of polygon is that it is a closed figure with sides and vertices. So it's not like it could be a circle or anything else. So a polygon is a closed figure. If it has three sides, then that is the definition of a triangle. So it is always. Okay, an equilateral triangle, blank isosceles. Remember, if it is equilateral, it is going to have all sides equal, which means it's always isosceles. But an isosceles triangle does not have to be equilateral all the time. So you have to know the difference between these two. Scalene, meaning different in sides, can't be isosceles. Okay. Go ahead and go to your next slide. Okay. An equilateral triangle, which all the sides are equal, is always equiangular. If all sides are equal, then all angles are equal. And we're going to talk a little bit about that. If all sides are different, then all angles are different. A triangle with one right angle is never acute. If it has a right angle, then it's a right triangle. A triangle never has two right angles. Remember, 90 and 90 already make 180, so we can't have more than 190 degrees. Can never have two obtuse angles, and a triangle always will have two acute angles. Now, sometimes it might have three acute angles, but no matter what, it will always have two. So that's just our introduction to a triangle in the interior sum. What you have to get out is that the interior of all triangles is 180 degrees. Okay, this is where it came from, that I can put my alternate interior angles up here, and X, Y, and Z would be 180 degrees. And then you need to know the types due to their sides and the types due to their angles. Have a good day.